Alright, so welcome to the video lecture series on Introduction to Computer Networks. This is part 3 of the video lecture on the topic of the Internet Protocol. So we will jump to the point from where we left off, and here we go. So we know that there are 5 different classes of IP addresses in classical IP addressing, namely classes A, B, C, D, and E. And we will try to break it down a little bit further to understand how other information could actually be inferred in the way the bits are organized for these IP addresses. So for class A addresses, we know that the first bit is set to 0 and we cannot change the first bit. So we can only change the remaining 7 bits to generate different combinations of the network ID. So this means that if we look at the way the IP address would be converted into a binary representation, we know that the first bit is set to 0, so that is something that we cannot change, and the remaining bits could be 0 or 1. So if you look at the way the bits are laid out, so we have 7 bits that we can change, which means that for each bit there are 2 options, so that means there are 2 to the power 7 combinations that we can generate for different network IDs. However, there are 2 addresses which are special and that we cannot use, where we have all the bits set to 0 and where we have all the bits set to 1 for 127. So that leaves us to a total of 126 different network IDs that we can generate for Class A addresses. However, the more interesting part comes with the fact that Class A addresses are used for large networks where we have many hosts. And it follows the same reasoning. That is, for the host IPs, we now have 24 bits that we can play with and generate the host IP addresses. So that means there are a total of 2 to the power 24 combinations for the host ID part, right? And there are 2 special addresses. That is where we have all the bits set to 0s, and the other one is where we have all the bits set to 1s. And these 2 addresses are the network address and the broadcast address. So that is why we subtract 2 from here, and therefore we see that we have a very large number of host IDs that we can generate for every network ID. So if we look at an example, so let's say we have a Class A address where the first bit is set to 0 and that is fixed, and we say have an IP address which looks something like this. We don't really care what the value is, but this is the network ID specified by the first octet. So now for the remaining 24 bits, we now have 2 to the power 24 minus 2 IPs that we can generate, and all of these IPs will fall into the same network ID. So that is why Class A networks have the usefulness of being allocated for very large networks where we have many hosts which are connected to a single network. So similar reasoning can be applied to Class B addresses, and here we have the first 2 bits fixed to 1 and 0. And we know that the first 2 octets are used for the network addresses, So therefore, we only have a remaining 14 bits to play and generate multiple different network IDs, which means that there are a total of 2 to the power 14 different network IDs that we can create. And the remaining 16 bits that we have result in 2 to the power 16 minus 2 number of host IDs that we can generate. And then if you look at it a bit closer, you'll see that there is the IP range, which says that class B addresses would range from 128.0.0 to 191.255.xx. And this is implied with the fact that we have a preset condition for the first 2 bits. So let's look at how this works out. So let's say we have the first octet right here. And we know that the first 2 bits are set to 1 and 0. The remaining, we know, could be zeros or ones. And this is only the first octet. And now if we have the second octet, in the second octet, any of these bits could be set to 0 or 1. So what is the lowest number that you can generate for these 2 octets? So that would be 1 0, and then all of these to be zeros. And in the second octet, all of these to be and if you convert this number, this is equals to 128, and this is equals to 0. So therefore, the first IP address for the network address, is 128.0. whatever in the next 2 octets, right? Next, if we say what is the max number that we can generate for our class B address, so that would mean that the first 2 bits are left to 1 and 0, and then all of these would be ones. So this is our first octet, which equals to 191. And for the second octet, we would have all of these to be ones, which is equals to 255. So therefore, the IP range for class B addresses stretches from 128.0 to 191.255. Class C addresses are useful for rather small size networks, and by now I would assume that you have gotten the idea how this is working out. So now we have many different network IDs that we can generate, and that is because we have the first 3 bits to be fixed to 110, but we still have 21 bits to flip between 0 and 1 and generate different network IDs. So 2 to the power 21 is a very large number. However, the host part is only 8 bits. So 2 to the power 8 minus 2 being for the fact because the first IP is the network address where every one of the bits are zeros, and the last IP where all the bits are ones is the broadcast address. So 2 to the power 8 is 254 number of host IPs that we can generate. And we also talked about the network mask for different classes and network IDs, where we said that the network part would be set to all ones and the host part would be set to all zeros. So for class C, the default network mask is 255.255.255.x. And if we just quickly look at classes A and B, so class A starts with 255, that is only the network bit, network ID part, the first octet, and the remaining part could be anything. The same goes for class B, where the first two octets are 255 and 255, and the remaining two could be anything. So classes A, B, and C are the common classes of IP addresses that we use for LANs. However, there are still two more classes, classes D and classes E, which are special classes of IP addresses. So class D IP addresses are reserved for multicasting, and here the first 4 bits are set to 1, 1, 1, and 0. They do not have any network or subnet mask because this is a special multicasting address. And if you try to generate the IP address range, it starts from 224 maximum value, minimum value, and it stretches up to 239.255, 255, 255. For class E, this is again a special class, and this is reserved for experimental purposes and not for public use. And here the first 4 bits are set to ones. For class E, we also do not have any network or subnet mask, and given the way that we have the first 4 bits in the first octet to be set to ones, the minimum number that we can generate is 240.000, and the maximum that we can generate is 255, 255, 255.254.